In this question, we are interested in finding the volume generated by rotating the region about the given line. So first of all, we want to take R1 and rotate it about line OA. So this line, which is just right here, is basically our x-axis, right? So we're taking this region, and let me see if I can find similar color. And rotating this guy with respect to this line, right? Very good. So let us begin. We know that the volume is equal to the definite integral 0 to 8 pi r squared. But what is our r, right? This is just an increasing line, right? Since you have this increasing line, you can easily find the y, which is equal to 1/4 x. This is going to be your radius. 1/4 x to the second power dx. This in turns can be written as pi over 16 definite integral of x squared dx, which in turns is pi over 16 of a third x cubed 0 to 8. Now plug in 0, make this guy to be disappeared. So you have pi over 16 times 1/3 and 8 to power 3. You can simplify this further as well, because 8 to power 3 is 8 times 8 times 8. Then you can just divide it by 16. So you have divided by 3 times 16, which is 8 times 2. So you get a 4. 32 pi over 3 is the volume that we have here. Next question. So now we are interested in rotating the region R1 about OC. Okay, OC, as you can see, is along y-axis now. So basically, we are taking this region and move it to the other side. We are rotating this with respect to, you can say that y-axis. But this is just R1, right? Very good. So since we are rotating this about y-axis, OC is parallel to y-axis, everything that we're going to write is in terms of y. So the volume is equal to the integral. Your y is bounded between 0 and 2, so no issue there. But for your object of rotation, take a look. Here you have a larger area dy minus the smaller area dy. The larger area, take a look. Your minimum x value minus the maximum x value is 8. So the distance here is 8. So far the volume is equal to definite integral 0 to 2 pi r squared dy minus, now for the smaller area, you look at this line, right? which is pi 4y to the second power dy. You just see this guy here, the distance 0 to 4 pi. Okay, the rest is just calculation. V is equal to pi, and you can just write this outside, 64 pi times y, and y is bounded between 0 and 2, minus 16 pi, a third. You have y cubed, y is bounded between 0 and 2. Okay, the volume can be calculated as 128 pi minus 16 pi thirds times 8. So if you try to simplify this, the volume is 128 pi minus 128 pi third. So here you can factor out 128 pi, 1 minus a third, which is, well, let us do the calculation, 256 pi divided by 3. So this is the volume. And again, if you want to get some approximation, you can basically use a calculator to do the calculation.